The Southern Ocean is home to the world's strongest and deepest currents that control the circulation of seawater across the entire world ocean. A key driver of this circulation is the decrease in sea surface temperature seen here in purple, with freezing conditions close to the Antarctic coast producing seasonal sea ice. Salt is rejected from the sea ice as it forms, leaving the remaining seawater salty, cold, and therefore very dense. Away from the coast, circulation is influenced by the speed of different surface features like eddies and jets. Scientists better understand ocean circulation by looking beneath the surface to the ocean's interior. Taking layers of constant density, known as isopycnals, we observed where the densest water sinks and then spreads across the very bottom of the world ocean. Antarctic bottom water is very dense water formed by freezing conditions on the Antarctic continental shelf, in places such as the Weddell Sea. As the sea ice forms, it produces dense shelf water beneath the ice, which then cascades over the continental shelf and into the ocean's abyss. Similar processes are occurring all around Antarctica. The energetic currents and features of the surface ocean hide pools of dense, deep water slowly moving along the ocean floor. The Ross Sea is another region where waterfalls of dense shelf water are continually feeding the bottom of the ocean. As this water cascades downward, it is pushed westward by the Earth's rotation and mixes with surrounding waters that are warmer and less salty, and therefore less dense. So properties of bottom water vary around Antarctica due to changes in local winds, heating, precipitation, and the ice conditions where they are formed. Away from the coastline, deep jet-like currents can be seen, mirroring the dynamic surface features observed in the water above. The energy from circulating flow structures, such as eddies and vortices, plays an important role in maintaining the broader dynamics of Southern Ocean circulation. A more complete picture of the ocean's structure is observed by stacking density layers on top of one another. These layers tend to angle toward the surface in the south, whereas strong eddies create hills or depressions in the layer, depending on the direction they rotate. Although strongest at the surface, where winds help to drive the flow, these eddies extend to the abyss and help pump deep water back up to the surface. While eddies are found throughout the Southern Ocean, there are particular hotspots of activity that are usually controlled by topographic features and islands. Off the tip of southern Africa, currents interact with topography to generate a train of Agulhas rings which propagate into the Atlantic. Much remains to be learned about the Southern Ocean. Observations combined with increasingly powerful models continue to yield new insight into this inaccessible part of the world.